Assalamu alaikum everyone. I hope everyone is fine at home and you have done your homework. Last time we were discussing multiple integrals. So today we will continue our same lecture. So today I will solve some more problem from practice sheet number 5. So first question is from the sheet. So this is the third part from question number 1. So you have to integrate sine x plus cosine y from 0 to pi by 2 and from pi by 2 to pi dx dy. So now you know very well. So this limit 0 to pi by 2 is for x and pi by 2 to pi is limit for y. So what you will do, so first you will integrate this inside part. So you can put bracket like this, then it will be more easy. Now you will integrate this with respect to x. This is very important. You have to integrate with respect to x. So now you will integrate sine x. Now integration of sine x is minus cosine x. You know, derivative of sine x is cosine x, but integration of sine x is minus cosine x. And here is cosine y. Now you can see this variable y, but we want to integrate with respect to x. So it means cosine y we will treat just like a constant number. So it means the cosine y we write same, and the integration of 1 will be like x. So it will be x cosine y. So now, and limit is from 0 to pi by 2. So now you will substitute here limit, and you know you substitute limit in x because we integrated with respect to x. So you will substitute only in x. So we substitute first upper value, which is pi by 2. So this will be minus cosine pi by 2 plus pi by 2 cosine y minus. Now you substitute the lower value 0. So it will be minus cosine 0 plus 0 into cosine y. And now cosine pi by 2. What is the value of cosine pi by 2? It is 0. And plus pi by 2 into cosine y minus. And the value of cosine 0 is 1. So it is minus 1 plus 0 into cosine y, it is 0. So therefore we have pi by 2 cosine y and minus minus plus 1. So now you can integrate this with respect to y, and the limit is from pi by 2 to pi, and you know pi by 2 is constant, you can write outside, and then you can write integration of cosine y plus the integration of 1 from pi by 2 to pi. So we have written in this two integral now. So now integration of cosine y with respect to y, it is sine y. You know derivative of cosine is minus, but when you write integration, it is opposite. So cosine y, it will be only sine y, and the integration of 1 is y. And then you can substitute the value, upper value as pi. So it will be sine pi minus lower value sine pi by 2 plus, in this you can put the value upper value pi minus pi by 2. As you know, the value of sine pi is 0 and the value of sine pi by 2 is 1. So whenever you are calculating values of pi or pi by 2 from your calculator must be in radian, and then you will get this answer 0 and minus 1. So if you simplify this, 0 minus 1 is minus 1. So this will be minus pi by 2, and this plus pi by 2. So the answer is 0. I hope this is clear. If still there is problem, we can move to the other question, and we will see maybe your concept even will be more clear. Now part number 4, you have to integrate from 1 to 2 y to y square dx dy. So now first you can integrate inside. So again inside is this is your inside. So it means y to y square dx. So this inside part, and then later on you will integrate from 1 to 2 dy. Now integration with respect to x. So the integration of 1, because you know if there is nothing given, so 1 is always given. So because 1 multiplied with anything, it will not change. So that is why I have written here 1. Maybe some students, they are thinking from where I have written 1. So the integration of 1 is x, and the limit is from y to y square, and then you can put upper value. So this is y square minus, you can put the lower value y, and now you can integrate with respect to y. So integration of y square will be y power 3 over 3, you know the formula, minus integration of y is y square by 2, and then you can substitute limit from 1 to 2. First you can substitute the upper value 2 in y, and minus, then you can substitute the lower value 1 here. So this will be 2 power 3 minus 2 power 2 over 3 and 2, and and then minus, you can put the lower value 1 power 3 over 3 minus 1 power 2 over 2. So you can simplify this. 2 power 3 is 8 divided by 3 minus 2 power 2 is 4, 4 divided by 2 is 2 minus 1 power 3 is 1, so 1 by 3 minus 1 power 2 is 1, so 1 by 2. You can simplify this, so this will be 8 by 3 minus 2, so this will be 2 by 3. If you can simplify this, so because 3 into 2 is 6, so 8 minus 6 is 2, so 2 by 3 plus, if you simplify this, so this will be 1 by 6. You can solve with the calculator if you don't know how to solve, but the answer will be 1 by 6. So then if you simplify this again, so this will be 5 by 6. So this will be answer. Okay, now we move to the next question, question number 2. Find the volume of the region bounded above by the elliptical paraboloid z is equal to 9 plus x square plus y square, and below by the square r, which is x varies from 0 to 1 and y varies from 0 to 3. So if you know, formula is given in the practice sheet. Formula is already given. So volume formula. So volume formula is already given. So you can see here the value of x. The limit of x is from 0 to 1. The limit of y is from 0 to 3. And what was the formula? Formula here you write your z is equal to f of xy, because this z is a function of xy. So that is why we write here f of xy in the formula. If you will see, so there is written f of xy, because z is a function of xy, so this is actually z, this is equal to f of xy. So your f of xy is given as 9 plus x square plus y square, and why we have written here dy, because this 0 to 3 is limit for y. So you can write here even dx, but then you must write 0 to 1 here this limit, and then 0 to 3 outside. So this you must be very careful. If you write here dy, then inside you must write the limit of y, and outside if you write dx, then outside you must write limit of x. Now next is same, you have to integrate this. So first you will integrate with respect to y, and then later on you will integrate with respect to x. Now if you integrate with respect to y, so if you integrate this with respect to y, so the integration of 9 with respect to y, it will be 9y. Integration of x square with respect to y, because x square we will treat just like constant, and we are integrating with respect to y, so it will be x square y, because you can see here 1, so integration of 1 will be y, and plus the integration of y square, it will be y power 3 over 3, because you know the formula y power n plus 1 over n plus 1, so it is 2 plus 1 over 2 plus 1, so y power 3 over 3. And then you can substitute the limit from 0 to 3. So first you substitute 3, and then you substitute 0. So if you substitute here 3, so 9 into 3 plus x square into 3 plus 3 power 3 over 3 minus, if you substitute 0 here, so if y here 0, here y 0, here y 0, so this all becomes 0, so it will become 0. Now you can simplify this. So 9 multiplied by 3 is 27 plus 3x square plus 3 power 3 is 27 divided by 3, it is 9. So 27 plus 9 is 36. So 3x square plus 36. And now this is simple integration. You can integrate with respect to x. So the integration of x power 2, it will be x power 3 over 3, and you written 3 same, plus integration of 36 is 36x, and then you can substitute the limit first 1 and then 0. So if you substitute here 1, so it will be this 3 and 3 will cancel, so 1 power 3 plus 36 into 1 minus, you put 0, so 0, this one will also be 0, so this will be 37. So I think very simple, only just remember the formula, it is same like the double integral. So simplify this and you will get the answer. So now next is double integral of non-rectangular region. Previous was the rectangular region. Rectangular region, so this was when you take limit like 0 to 1, 0 to 3, so it means a to b or c to d, so this will become like a rectangle. But if it is not a rectangular region, so then what we will do, so note that for non-rectangular region we use Frobenius theorem, stronger form given in the practice sheet. So what is that theorem? Theorem says let f of xy be a continuous function on a non-rectangular region R if R is defined by x varies from a to b and y varies from g1x to g2x. Now here you can see previously Y vary also from A to C to D. Now instead of number, there can be some function g1 x, some function in x, and g2 some function in x. With g1 and g2 continues on a b closed interval, then your double integral region in region R f of x y dA equal to a to b g1 to g to x f of x y dy, because this g1 g2 is limit for y, so we have written dy and then dx a to b. So because this x is in a limit, so a to b, so this will be a to b will be a number, so this you must write first, and then here this will be a function, so this you must write inside. If you write function outside and this limit inside, may so at the end you will get answer in variable, so but we want some number. So if R is defined by C to D, now instead of if here instead of x in y, there is a number given C to D, but in x, now here instead of number there are some variable some function given. Then what will be the formula? If R is defined by y varies from C to D and x varies from h1y to h2y, with h1 h2 continues on CD closed interval, then double integral R f of x y dA equal to C to D h1y to h2y f of x y dx dy. So it means this now is limit for x and this is limit for y. Now first we integrate with respect to x, and then later on we'll integrate with respect to y. So sometime we'll use this formula, sometime we'll use this formula. Actually it depends on the region, what region is given, so accordingly we will use this formula. Now we will solve first example, the question number 3 from this sheet. Find the value of the integral double integral R sin x over x dA, where R is region bounded by the x-axis, the line y is equal to x, and the line x is equal to 1. Now this question is very interesting. Now previous question were straightforward, because they were rectangular region and the limit of x was from a to b and the limit of y was from c to d. It was very simple. But here now first you have to draw the graph of this and then you must solve, because otherwise you don't know what will be the region and what we have to write limit for x and what we have to write limit for y, because here it is not clear. So now in the question it is bounded by the x-axis. You know the x-axis. So this is your x-axis. So bounded by this x-axis, the line y is equal to x. You can draw the line y is equal to x. You can put here value x0, then y0, x1, y1, x2, y2, and you can put x minus 1, y minus 1, then you can join. So you will get this line. You know how to draw the y is equal to x line. And the line x is equal to 1. So if here is x is equal to 1, you can draw this line x is equal to 1 like this. And now you can see what is the common region. So this region which is bounded by x-axis, the line y is equal to x, and the line x is equal to 1. So this is our bounded region. So because the question was where R is a region bounded by these lines, x-axis, line y is equal to x, and the line x is equal to 1. So now we are interested in this region. Now what will be limit for limit in this region? Now if you see here your x varies from this x. So x here x is 0. You know on y-axis the value of x is 0. X varies from 0 to 1. X varies from 0 to 1. And y varies from where to where? Y varies from here. So this y 0. Here y is 0. So y varies from 0 to, we will not say y varies from 0 to 1. If you say y is equal to 0 to 1, so then this will become a rectangle. But we are interested in this region, and this is not a rectangle, this is a triangle. So y varies from 0 to y is equal to x. Y is equal to x. So that is why we are writing here x varies from 0 to 1 and y varies from 0 to y is equal to x. And then sin x over x, and because this is limit for y, so we write here dy, and this is limit for x, and then here we write dx. Then it is very simple. And now it means x varies from 0 to 1, y varies from 0 to x. No need to write this y and this x. And sin x over x dy dx. Now first you will integrate with respect to y. So this sin x over x, because when you integrate with respect to y, this will be all will be just like a constant. You can write outside. So it means only 1 is left. So integration of 1 will be y. And then limit from 0 to x. So you can put this value in y. So this will be x minus 0, because if you put 0 here, so this all will be 0. Now this x and x will cancel, so we are left with only sin x, and you can integrate sin x, so which is minus sin x, and then you can put upper value 1 and lower value 0. So it will be minus cosine 1 minus, and then cosine 0 minus is plus 1. So cosine 0 is 1. So minus cosine 1 plus 1 is your answer. You can simplify this more if you want, but you can stop even here. There's no problem. So I hope today lecture is clear. So try to solve all these questions one more time at home, and from practice problem you can solve some other question. So if still you have any question, any problem, I will be very happy to answer your question, your problem on our Moodle live class. So in next class you can ask any question, any problem. So take care of yourself, stay at home and stay safe. Assalamu alaikum.